video, we're going to be using different geometric figures to help us solve problems. Here you'll see an array of different three-dimensional shapes, some of which we'll be focusing on more. Here we have an example of a rectangular prism. All of the sides are rectangles. The top and the bottom faces are congruent rectangles. The two different ends are congruent rectangles, and then also the front and the back face are congruent rectangles. In these figures, we talk about taking cross sections, what the resulting shape looks like. If we're to talk about a cross section parallel to the base, meaning if we were to cut this horizontally, we would end up, if we were to cut it horizontally in half, and look at the cross section that we have with another rectangle. We can also cut these shapes and down vertically, which we refer to as perpendicular. If we do that, we are going to end up with a rectangle where the resulting figure is the exact same rectangle as our sides. So a perpendicular cross section to our rectangular prisms will result in a rectangle that is the same as our actual side. And then of course we can do diagonal cross sections as well, which will result in a parallelogram. So if we were to cut through this not evenly, but at a random cross angle, we are going to result with a parallelogram. A real life example of a rectangular prism, something as simple as our cereal boxes. So if you were to go chop up your empty cereal box, and you could yourself see these different cross sections. Moving on to a different figure, we can work with our rectangular pyramids. Of course, we can take cross sections parallel to the base, which will result in the same shape as our base, a rectangle. You'll notice, of course, as you go up higher, even though you are resulting in rectangles, your rectangles are just getting a little bit smaller. But it will be a rectangle no matter where you take that parallel cross section. If we were going to go straight through the vertex, the very top of the pyramid, and cut, you're going to notice that you end up with a triangle. It's going to be the same as the side face, a triangle, the same shape, it's just not going to necessarily be congruent. If we were to take cross sections, not through the top, but instead go on either side of that vertex, not through the top vertex, we're going to end up with trapezoids, because each angle is going to be angled to the side, but your top and bottom are going to be parallel to each other, resulting in these trapezoids. And of course, when we think in the real world of pyramids, one of the first things we think of are the actual pyramids, the ancient pyramids. But there's also many different architectural shapes that are used, including pyramids in many different building structures. Of course, we have many different 3D shapes that we can take different types of cross sections of. Here we are focusing on 4 different: a cylinder, a cone, a sphere, and a square pyramid. Notice before we were working with a rectangular pyramid, and here we have a specialized version being the square pyramid, where the base is a square. All of the sides at the base are the same length. And we can take parallel cross sections, perpendicular, and in this case we're taking diagonal cross sections like we did before with our rectangular prism to result in different shapes. This is a great chart to pause and make sure you are copying it down in your notes. If you can't remember all of these or visualize them all, definitely save this somewhere in your notes and create your own if you want chart. That way you have it for your use to always refer back to. Ellipses are a special type of shape. Most people look at them and maybe think of an oval, but there is a mathematical definition behind an ellipse. It's a little bit different than an oval. And in the spheres, you will notice that any which way you turn a sphere, it looks the same. So any cross section is still going to be the same. So if you haven't already, pause now and go ahead and copy this down for your notes. Now we've been taking 3D shapes and cutting them, creating 2D shapes and what those cross sections look like, but we can go the other way as well. We can take a 2D shape, rotate it around the y-axis 360 degrees, and result in a 3D figure. Sometimes students have a lot of trouble picturing this. So if we take a rectangle and rotate it around, what shape do we result with? One way to think of this is a rotating door. So if our original figure is our rectangle that we have, and we rotate it 360 degrees around, we remember the bases, the edges of it is all going to be the exact same distance from the center, which is our y-axis. And any shape that has the points all spread out the exact same distance from the center results in a circle. So our top and bottom of this rectangle actually result in a circle figure, but the sides on both sides will be the same. This figure, if you haven't thought of it yet, is actually a cylinder, a circle at the top and bottom with the heights on either side being the same. So taking this concept of as we rotate the bases of this rectangle around, resulting in a circle, any width anywhere along it is going to result in a circle. So if we were to take a right triangle, base is going to result in a circle. Notice though, because the hypotenuse is getting closer and closer to the axis, the circle slices are going to get smaller and smaller and smaller, resulting in just a point at the top. That leads us to a cone. In this case, kind of an upside down cone, because our base will be big, our top will be the point. So we have our cone. If we were to rotate the right triangle 360 degrees. We can also do the same thing with a semicircle. Obviously, the middle is going to be the largest circles here. And going towards the top and the bottom, the circles are going to get smaller and smaller, resulting in a 3D sphere. So again, take a moment, pause this if you haven't already written this all down, and jot this little chart in there. But hopefully the idea of that rotating door helps you understand why we're resulting in those circular slices. Now, sometimes we're not having to really think of the 3D shape created or the 2D shape created, but we're just having to use our geometry skills to help us figure out different problems. So if I have a patio and I know it's a trapezoid, but I need the area, and let's say I cannot remember the area of my trapezoid. Well, I can take and look at this trapezoid and recognize, oh, well, I have a triangle on both ends, and I have a rectangle. Now I can use the formulas I do remember to help me figure out my area. So I know that for my rectangle, the area of my center rectangle is going to be length times width, which is going to be 3 times 7. These are yards. So 21 yards squared. For my triangles, I happen to remember that the formula for area of a triangle is 1/2 base times height. So I'm going to have 1/2. I know my height is 3, but I'm not quite really sure what my base is. What is this measurement right here? I know the whole thing across is 7. I know this piece, just this piece, is 7. The whole thing across the whole entire trapezoid is 12, but I need this missing piece as well. Well, 12 minus 7 gives me 5. If I divide that by 2, that's going to give me 2.5. So I know my base is 2.5. I plug that all in a calculator. 1/2 times 2.5 times 3, and that gives me 3.75. Again, I'm working with yards, so I know it's going to be yards squared. Notice I have 2 triangles, so if I need to add up the area of the whole thing, I'm going to have 3.75 plus 21 plus 3.75 again. I don't have to rework the whole formula because I know it's the same figure based on this trapezoid. Add those all up, I get my 28.5. Always want to include my units. So I'm going to have 28.5 yards squared as my area of my patio. I guess it's kind of a small patio. And then the last concept we want to make sure we cover is density. Density is the ratio of mass to an area or a volume. In this case, we're going to be using volume. And it's also important to note when we're talking mass, it doesn't necessarily have to be a mass like you would think of in science class that's similar to a weight. Here we're looking at as how much matter is in an object. So we can represent our matter as people, as objects, things like that. So here we're asked what's our density of our fish tank. I know density is going to be the mass over the volume. In this case, my mass is going to be, well, how many of fish? I need to figure out the number of fish. I can count my fish tank. I count there 1, 2, 3, 4, 5, 6 fish. So I know it's going to be 6 fish over my volume. I don't have my volume, but again, I can figure out my volume. Volume equals length times width times height. 3 times 1 times 2, that gives me 6. I'm in feet. It's a volume, so it's going to be cubed. So 6 feet cubed. So 6 fish per 6 feet cubed. 6 divided by 6 gives me 1. So I have 1 fish per, that division bar we can write out as per foot cubed, or per cubic foot in my fish tank. And then of course with density we can go the other way as well. So we can be given a density and need to find out something about a problem. So here we're given this restaurant. We're told what the density can be, the maximum. They also give us the volume of the restaurant, and they want us to figure out, well, how many people can be in there? So again, I take my formula. Density equals mass over volume. I know my density. They told me 0.075. I don't know my mass. That's what I'm trying to figure out, how many people are in there. I know my volume, 2,000. Well, 2,000 is in the denominator. I need to get rid of it. I'm going to multiply both sides by 2,000. 0.075 times 2,000 gives me 150. I can just plug that in my calculator to calculate. 150 equals M. So how many people can occupy the restaurant at any given time? 150 people. Hopefully this has helped you out. You can now use real-world objects, classify them, use them to solve problems. You know about cross-sections, rotations, and you're also able to use density. If you need any further help, be sure to check with your teacher or the tutoring hours. Have a great day.